All right, hello, welcome to the Off by One security stream. This is an interesting one because it's 1 a.m. in California where I normally live, but I'm coming from Bangkok, Thailand right now, where it's 3 p.m. And Leon Jacobs here is in South Africa where it's, I believe, 10 a.m. So interesting time, but it's all good. We make sure the stream happens no matter where we are, or at least we try. But welcome everyone. Oh, I wanted to point out real quickly, this, I don't know if you're gonna be able to see it very well, but like we finally got some merch. So you can see like that's the back of the shirts and the hoodies, and then like the front just kind of has the Ida skull thing that the guys from Miscreants created. So we're gonna have those up on a store pretty soon. All the proceeds, of course, go straight back to the community. We're just going to put a small margin. If you on Discord, you see it's all transparent. Like until we find the right, like I want to find the right shirt maker and hoodie maker and figure out how to get the good price point. So it's as low cost as possible, but a little bit of a margin so we can add some to the pot to like send people to DEF CON and the things we like to do to get back to the community. So if you are interested in those, I will be posting it up on X, of course, and on Discord. But anyway, so welcome everyone again. We've got Leon Jacobs here. He recently spoke at DEF CON, and this is a nice way. I was just telling him right before we started up here that we started doing this thing, and I hope people don't steal my secret, but where we're going to conferences, and if we see someone who did a good talk, or even if we're not there and it looked like a good talk, good reviews, then we're like reaching out and saying, hey, would you like to do a stream here and just have more time, more flexibility? You don't have to be rushed by a clock where you only have 35 minutes to present everything and have to worry about the demo gods. So it's like a really cool way for those interested in sharing their research to kind of have a little more time and fight with the demo gods. So anyway, so today our topic is vulnerability discovery in Windows bloatware. I'm going to ask Leon now to give a little background about himself and maybe tell us a little bit more about what he's going to be sharing.
Okay, I'm going to go with good morning. It's 10 a.m. over here, but I know that's not true for everyone. Thanks for your time. Appreciate you inviting me. I'm definitely excited to share a little bit of this. Very quickly about me, I'm a security guy. I work in South Africa for an organization called Orange Cyber Defense. In their SensePost team, it sort of focuses on ethical hacking predominantly, but Orange Cyber Defense does quite a large amount of security work more generally. So the work today, everything will be live demos. Literally, as we go through the reversing, we go through the discovery of 2 of the 7 vulnerabilities that I found. And the reason why I'm only going to do 2 is because we're going to go through all the detail. If you want to see the other bugs, it's sort of all in the reference material for the DEF CON slides or the ROM hack slides that you can find online. But we'll do 2 today. So the first will be the ACES one-click RCE, sort of the process I went through from initial discovery, which is a little bit of a, why is this happening, to what is happening, and then sort of leaning into that energy into finding an LPE in Razor's new Synapse app. All of these things have been patched. So if you have the latest versions and you insist on running the software, then at least update. This will be good for you. But ideally uninstall this stuff. But yeah, so these things are fixed. But we're going to go through the details and how I found it and what we can learn from there. Like I was saying earlier, before the stream, this is kind of the perfect scenario because I know a vulnerability exists. So it's a little bit of a fictitious setup that we kind of know what's going to happen. In the real world, you don't know. You're kind of sort of fumbling around and poking at things and learning. So there is an element of when these things are going down for real, the results of which many of things I looked at didn't turn into a vulnerability. So you sort of have to fight that. When do I stop? When do I continue? I think a lot of folks go through that. But yeah, so that's sort of the thing. All live demos. One thing that might be strange, I need to keep reverting a snapshot because there are updates for these things. The moment I connect it to the internet, it downloads new things. So we're going to do a few hacks to just get past that. But yeah, that's sort of what I have planned for today.
Awesome. Yeah, a lot of requests come in on the Discord. We have a stream request channel, and a lot of people are asking for just any kind of vulnerability research. Just like, how did you stumble upon something? What's your approach to look out for something? What do you do when you think you found something? Just the tools you use. So I think that's a lot of what you're going to be sharing with your kind of mindset and such. So it's great.
Yeah.
As usual, I encourage questions from everyone. If you have a question that's related to what's being discussed at the moment, I will try and interject and see if it's a good time to ask Leon. He may, of course, say, well, I'm going to get to that soon, or let's save that for the end of the stream. But we always encourage questions, so please feel free to post those. And we'll have a little time for Q&A at the end as well. It's funny, the first question I got on the Discord is not an offensive question. It's what immediate hardening steps do you recommend for enterprises to do to have to run vendor updates? And also, is this anything similar to the tool Evil Grade? Are you familiar with that tool Evil Grade?
No, that's not ringing a bell.
It's an older tool that worked better. Like SourceForge, for example, used to work over HTTP, like way longer than it should have been running over HTTP. And there's so many applications out there that do automatic checks for updates, or like you can go in and say check for updates. And for HTTP, it's just you get machine in the middle, and then you pass over an interpreter payload instead, and it just yeah. So
makes you think of that backdoor factory stuff. I think maybe it's an interesting point. So none of these vulns are directly exploiting update mechanisms in the sense that we're sort of in a network position where we can determine or influence some network traffic. Although the ACES bug does have one code path as an update related code path that we're going to exploit. But I think in principle what's really interesting here, and that was sort of the theme of all of this research and something I still look at. You're going to find artifacts in my VMs for other products that I've looked at. But there's sort of this idea that I have that I think there's a opponent triad. One, if there is a service that is in an elevated state, running a system, running as some sort of administrator, that's already the first interesting property. The second property then is what kind of RPC does it have? You're going to see an HTTP-based one today. I don't want to spoil the second one yet because I had a bit of a hard learning there, but there's another mechanism coming later today. Sometimes it's just an arbitrary TCP socket with a custom protocol. Whatever mechanism the software vendor allows that elevated process to be interacted with, those things are always interesting to me. So that's sort of the second thing that's true. Is the first something running in an elevated context? Two, how does the mechanism for someone to interact with that look? And then three, like what are the interesting features? What can I do? Can I trigger an update? Can I have a code path that runs a command? Spoiler alert, that is true for some of these things, which is fairly ridiculous. But really my focus for this stuff is there an elevated service? And that's usually when I start getting interesting. Why does it exist? And what can I do to interact with it as a start? So not really update related things.
Nice. Well, let's do this one quick question because the easy one from Gareth, and then I'll let you get started because I know you got a bunch you want to share. But what was the time frame to find all 7 of these issues, and how long did you spend with them?
So the title of the talk is 7 vulns in 7 days. No jokes. 7 days for all of these vulnerabilities.
That's legit.
Yeah, but I think 2 things were true there. I got very excited after the first bug, so the amount of energy I had was bigger than me, and so I just honed into that. But then I think a second part is these vulnerabilities are just really silly. Like, for the Acer one, for example, you connect to a name pipe, you pass it a path, and it'll run that code as system. Like finding that, it doesn't take very long. And bonus points is written in .NET. So you open it in something like dnspy, you're kind of doing a code review. You're not, doing C lower level languages that you need to reverse. That's, for me, a little harder than I would say .NET would be. So, finding that code exec didn't take too long. Other ones took a little longer. But yeah, those are 7 vulns in 7 days. And I was absolutely broken at the end of it. This is also something to keep in mind. Like the mental state was, I can't look at this anymore. I'm over it. But there are also many failures. One example I really like is there's a product called Lenovo Vantage. And I had a look at it, learned its RPC mechanism, started looking for code paths that I could manipulate in interesting ways, because it also matched this elevated service, interesting RPC. You could do interesting things. And I couldn't find a vulnerability. And maybe about 2-3 weeks before the DEF CON talk, a Tradies Partners release a blog post with some like really cool hackery where they managed to get code execution in the same product. Yeah, so just because you're done doesn't mean there's no bugs. Someone else, might know something differently. So they abuse some interesting registry primitives that I thought was quite interesting. If you've got a chance, go check a blog out. But yeah, just a different avenue. I wasn't really focusing on registry things. I wanted really low-hanging, easy things, and yeah, success.
Yeah, it's awesome. Yeah, this one guy, I won't mention his name in case he doesn't want me to, but he's on the Discord a lot for Off by One, and he's just one of these people who just is very curious and will use different syscall interception tools or whatever, and just like start poking and prodding at different things and finding different types of vulns, just a completely different way than reverse engineering and stuff. And like some people are just really gifted at finding problems in different ways, so it's awesome.
Yeah.
But yeah, let me I'll go ahead and we'll share your screen and you can go ahead and get started, and I'm sure people
Okay,
want me to
let
stop
me do
talking.
this
So
screen. Okay, so I'm going to start with a VM. Let me know when the sharing is up, and then we get going.
it's good. Yep.
All right, we're going to see this VM a few times. Feel free to look at my desktop. It's awful, but this has ACES driver hub installed. This is an old vulnerable version. Has a little tray icon at the bottom. I see it's already told me it's got an update available. I'm actually going to go ahead and click that. This is kind of how this started. I had this tray icon on a physical machine I have here in my office. And this is sort of the interaction that I experienced with it. I really like that this still exists. These are the two vulns that I found. So this is the real driver hub at aces.com that still has the warning for the two CVEs telling me I need to update. That that shows in a banner. This, of course, is a Parallels VM, and ACES driver hub tells me this is not a ACES product, which is fine. They're not wrong, but we're going to get past that in a sec. So, I think the first point here is this is sort of the interaction. We'll see in a second. It has this like menu that you can choose driver updates you want to install or not. Now, the first hurdle, after I saw that on the physical machine, I realized I actually need to install this in a VM in Parallels, because snapshots are nice. If I mess things up, I can revert, etc. I think most folks get the benefits of that. But the challenge is when you try and install ACES driver hub, which I have in a share here. This is the installer that you would download. I think this is the fixed installer as well. The little setup screen here will show you this is not an ACES driver hub. Tells me this is not an ACES product. It's not wrong. It isn't. But we can get past this stuff. This is, I think, the latest version. So this is not the vulnerable one. So one way to get past that, we'll open our favorite tool, Binary Ninja. I'm going to open that installer, which we've had already. And the reason I choose Binary Ninja, just sort of throw it in there, and just if it pauses, a little bit of a lazy way, like, oh, okay, this is clearly a native code that has been compiled, so Binja can do its job. Some quick triage summary, useful view if you haven't seen that, just get a sense of what sort of target, what kind of compilers were in use. They're not always important to know, but it sometimes influences a little bit if you're dealing with different runtimes, just to get a bit of a quick overview, what it imports, etc. Okay, so the trick I like to use is strings, and I don't think this was going to surprise anyone. That installer tells me this is not your device is not supported. So I typically search for your device, maybe. No, one more sec. Let's go with supported. And we can expand this a little bit. So one of the things that is support motherboard. Those look like strings that are related to the feature I might be interested in. If you double click it, it'll show you the section that has it. On the left here, there are cross references. So which functions are referencing this string? If I go there, this sort of starts giving me an idea of like, okay, here's a function that relates to that string. I'm looking at the high-level interpreted language. You can do pseudo C, which is mostly the same sort of view. I can look at the assembly if I wanted to, but that's a little harder than for what I want. So I'll usually have like a cursory scan, look at the function, get a quick sense, predominantly based on string references. What is this thing doing? And without really knowing what all of these function calls are doing, I could kind of conclude that this looks like it's trying to see if this is an ACES motherboard or some ACES product in some way. Now, one of the things we can check is who calls this function, which helps build a bit of a mental model on which functions are calling which takes a little bit of time in enumerating how a process works. Again, just by clicking that name, we can see that we land in a different function, which just happens to be main again. There are some startup things. flags, etc. I'm going to try and save some time over here. But we remember this function call we had gets an assignment to a variable that has a check that if it's, I'm guessing, true or 1, it does something that looks like a logger. Maybe this is a logger function. All right, so that's an interesting part to check out already. We might want to check for different references. Potentially there will be, oh, here we go. If there is a assignment to this variable, we see RSI, the register is assigned here, and there's a code path that jumps away somewhere else. So it goes down a little further down here. Eventually, you'll get to some section of the code over here when we, I need to double check where this is, because this is not matching what I thought it would be right now. Bear with me. Somewhere one of these checks would say, okay, this is not, it returns 0, so it's not a function. Let me just quickly scan it a little further to make sure I am not missing it. Maybe there's another reference to this function. There's only this one, hey, yeah. Okay, this is a little bit different to what I've seen over here, and it's not really where I want to focus now. Let's just quickly check this reference. Maybe it's a different function. Is it the same one? An assignment occurs here. Oh, this is still within the parent function. Sorry, bear with me. Still the same one. Okay, anyways, the point is, this looks a little bit different now. I think maybe there's an update or something to this code path. I don't really want to go through because this is the latest version. It looks a little bit different to the installer I had. But let's assume for a moment this check here would have been just a raw exit, what I remember from the previous installer. In Binary Ninja, you can apply a very quick patch. So I can right-click this. There's a condition over here that if that's potentially true, which could be this is not a supported product, we can right-click that and we can go to the patch section and potentially invert the branch, which now means if this is not true, then this code path won't run and the app can complete. When you finish doing that, you sort of save a new version of that installer. And when you then install it, the actual installation process will finish because this code check has now been, or this check here has been inverted, which gets you to pass this thing and you can install. I'm sort of purposely skipping this because this is not really where the interesting part is yet. It's just interesting to know that these installers, kudos to them for trying to not install their stuff on non-ASUS products, but not great. A little bit harder for you if you want to run this in the real world.
Have you had much luck and used the MCP server for Binja at all? For aiding in that type of stuff?
You'll notice this is the free version, which doesn't have any plugin support. Yeah, so you can get quite far with that. For the MCP stuff, I'm sort of experimenting a bit with the Ghidra implementations, of course, because it's free. But there's quite a bit of stuff written by Clear Blue Jar. They've done some objective by the C talks recently as well about MCP and Ghidra and patch diffing over time, which is pretty cool. Okay, so one thing to check over here, and there's a bit of this is how the story went. We got to install things, and I had this reboot modal, and I sort of got it really sussed, like what is going on over here? So if you open the network tab in your browser, you'll start noticing that there are calls that are being made down to localhost. Now, this is the real driverhelp.asus.com that anyone on the stream browsing there now will see this, and it's trying to make calls down to my local host. What's interesting is if these calls fail, you get download ASUS driver hub installer. If it's able to connect to the web server, it sort of assumes it's installed and then starts interrogating it. But we all know a web hacker's favorite tool is burp. So if we fire up burp, we can start inspecting what this looks like, or what those interactions look like, and potentially mess with them. So let's get that started. I'm going to start a proxy. This is a free version again of burp because getting my license from my laptop into here is pain. But more importantly, if you're hacking other things, it's possible to proxy into a VM. But in this case, it's interacting with a local web server, so it gets a little messy. If we look at the proxy history now, we should get a bit of a sense of what's being downloaded. These are just some web-based assets, a whole bunch of options calls. We'll do that later. But one call, that's a GeoHub. One call here is a GET request. Oh, I'm gonna need to fix that font. Give me one sec. User interface, message editor. Let's go for 16. That should be a bit better to see. Okay, so we'll see one request here for an initialize on this web server that's running on my computer. We'll inspect what that is in a sec. And it gets a response coming back, setting its version. Of course, the is support is false. So we can sort of make an assumption here that that's probably how the web interface determines that this is not a product that it supports. I'm not sure why in its default state is ACES is true, whatever. But that's an interesting thing. And because this is a web-based thing, we can obviously replace that. So we can make is support true and sort of see how it behaves. Now, to save a little bit of time, I've got some match replace rules I'm going to import in a sec that does exactly that thing. The next challenge we have, because these things have been patched, the version I have running is this 1049. But when you look at this next request, which comes from Driver Hub itself, it's a little bit of an indicator of what are the supported versions, etc. So if you do pass the check for, yes, this is an ACES product, it's going to prompt me for an update for the latest version, but that's no fun for the stream because that's fixed the vulnerability that I want to show you. So we're going to just mess with the initialize call here and say it's both supported, but it also has the latest version. So I've already prepared a burp config for that, which I'm going to copy here. Where is my desktop? This is sort of, you'll see what this looks like in a second. Let me just import these user settings on this desktop. Okay, looks like we're going to do it manually. That was hopefully going to be my trick, but it's not going to happen. The first chicken I should have sacrificed didn't work. Okay, so we'll do it manually. That's fine. So you have this match replace feature, which I'm pretty sure folks know. I'm just going to do a literal match for is support to is support true. And that'll come back from the response body. The next rule we'll add, this takes a little bit of work. We want to replace the version number in the response body as well. And then I just need to get a copy of what that supported version is. So again, this is just some really silly and annoying client-side hacking. This is not interesting from a vuln perspective yet. But this is why if you show the stuff after it's been patched, it gets trickier. Okay, cool. So now instead of this not supported page, if we refresh now, we should see some edited responses on this request. Hopefully, if I don't mess it up. Let's just see if this works. Yeah, so here is the auto modified. We have is support true now, and the version reported as whatever. And it's just because of these match replace rules we added some silly client-side hacking. Okay, so this gets us into a state where the web UI, sort of the web interface, thinks that it's interfacing with a web server that is an ACES product and is the latest version. And sort of one of the features, of course, there are no actual driver updates here. It doesn't have any of the ACES hardware UIDs and things, but there's this ability to install software using the Armory Crate installer. So that's an important one to take a look at. So the process of sort of figuring out what's cooking here, look at these requests. You'll see there's a WebSocket. I really didn't dive too much into it. It looked like a logging related thing. Maybe someone else wants to have a look at that, but I didn't pay much attention to that. But when you hit install over here, sort of the UI experience is something along this line. In the browser, this is the sort of thing where my brain started going, what's going on here? I just hit an install button in the browser, and in Windows, a pop-up comes along. In fact, the first time I really started thinking about this is after installing, there was a browser modal going, do I want to reboot? And I hit yes, and my computer rebooted, like instantly, which is very suspicious. I'm not going to install this. We'll look at this post request to an install app endpoint, which is highly suspicious. But you can see this is a post request down to some service on my computer saying it needs to install Armory Crate installer, and then a fairly uninteresting response. Okay, so that sort of sets the scene of we have a browser app that interfaces with a web server that's running on my computer. Now, I know this is going to be a little small to show you this, but I just opened Process Explorer. Sysinternals have amazing tools for you to sort of get an idea of what's happening on your computer. By default, it'll have a tree view, sort of gives you a process hierarchy like this. But you can sort of sort these processes by company name and sort of make an assumption that something might be signed by Acer. ASUS. Sorry, ASUS, whatever the correct name here is. I couldn't find that, which is now surprising me. Hold on. Okay, doesn't look like this is signed. Oh, I'm not an admin. That'll limit what you can see. Bear with me. Here we go. Asus Tech signing. This, you can sort of see the signatures. So this is sort of like a quick way of figuring out what company stuff is running on your computer. Interestingly, this is Acer, a different vendor. It doesn't have a signature on that. But anyways, and if you go through these things and I open this adu.exe, I know this is going to be too small, but the line you see here is a listening port on 53,000 on this adu.exe process. So that's clearly the interesting process that's exposing the web server if you wanted to browse to it directly, that is. One thing we can do, I actually haven't done this. Let's do localhost. Change back to Google. I don't know why you want to do that in my burp. If you want to, because we know it's a web server, if we don't go to localhost, but localhost, word. You sort of get a 404 coming back, which is interesting. So this is obviously an HTTP-based conversation that we're having, but the guess is we need one of these API endpoints that we can get to. We already know this, so we don't need to do any of this stuff, but sort of give you a sense. Maybe you haven't fired burp open yet. You don't want to play around. You can do that. Okay, so let's get to the interesting stuff. adu.exe is obviously an important binary here. I'm going to close the installer. I don't care about that. And I'm going to open adu.exe. I've already copied it off. This is the vulnerable version of this process that has the web server. So I'll have Binary Ninja do its analysis and whatnot. Maybe while that's happening, I think I can bump the font view. Maybe we can do a 16 here. Let's see. Yeah, that looks better. Okay. So this analysis might take a little while. It's not too big of a binary, but it's interesting. We already know, we can take a quick look at the triage, kind of get a sense of the compilers and other interesting data around this. You can see it's a 64-bit PE. But we can go back to the linear view and use a hacker's favorite tool called strings. And we know one of those endpoints was install app. So I'll search for install app. We can see a sense that here is one string reference, two string references that sort of relates to install app. And if I look at who is referencing those things, this one almost seems like mostly logging related stuff. This one looks like, I'm sort of making assumptions at this point. I know now, but when I was looking at this initially, I don't know. But maybe this is some sort of web root. So when I double click that to get a sense of which section has the string and or what else is around it, we can quickly get a sense of other endpoints that exist here. An initialize, device info, update app, and others, which is pretty cool. The one I actually initially looked at, there was a reboot endpoint somewhere over here. So I'm going to look at that. If I click reboot, we see two references in a single function that reference that string. So we'll take a quick peek at them. I'm just double clicking it to see where in the code section this exists. And we can start getting a sense of what's happening here. The first bits I usually do is sort of just look at the whole function. And you'll quickly get a sense that this looks like all the web endpoints that we've seen in the string section now in one big function. And conveniently, again, tells us this is the HTTP. This looks like HTTP initialization. So this might be the routing registration logic, where it just says which endpoints exist that needs to be dispatched off to something else. So I'm going to go look at that reboot one again, because I think it shows quite nicely what's happening here. There's actually two of them. So let me save you a little bit of time here. We'll look at that, click on reboot, and I'll go for the second one. The first one is, spoiler alert, the options request to this endpoint. The second one is the actual post request to it. And one thing you'll see here, sometimes you need to move back to the disassembly view to get a better sense. Like the sudo C is really just it's a nice way to get a sense of what's cooking, but sometimes you need to understand the calling convention and if it's an offset-based function, which function is it actually calling? But if you spot quickly here, it has this like light highlighting in binary ninja on this line, which sometimes gives you the idea that this does nothing. Like this assignment is not really used later. But that's something you sort of have to get used to, and it might confuse you and just thinking that there's nothing here. But this function is the actual handler for that reboot logic. So if I go into this function, things start getting very interesting. Bear with me. Reading this top to bottom is actually quite insightful. You're going to see a whole bunch of web-related things. All of those are headers you've seen before. Quickly scan through this, mostly focus on strings, these sort of pink highlighted text. You see more, probably the accept header, the content type that it's going to get. Here is a line of is origin allowed, post reboot. Okay, so you sort of get a sense that there's really something here that there's an origin check. There's some more parsing. I don't know what event means yet. Maybe to save some time, this is actually a whole bunch of JSON handling, but we can skip most of that. And eventually, hopefully I get to that before someone turns old, lots of JSON parsing. We get to a place where there are some Windows token manipulation occurring, which is interesting. And finally, this call to exit Windows. So what you learn here is that if you were to make a post request to this reboot endpoint, you could reboot a computer. And that's what was the original sort of spidey sense to me going, why? Why was this possible? And through the reversing, I realized, okay, there's an HTTP endpoint that just calls this Win32 API. Now, what's interesting here is this HTTP endpoint is obviously bound to localhost only, but I wanted to see if I can play with the other endpoints that we know of here. Are there any of these, like rebooting someone else's computer is funny, I guess, but it's bound to localhost. Like no one can read that over the internet or reach that over the network. And more importantly, what does the attack surface look like if I wanted to interface with this web server from a browser? And that was sort of my initial theory. If you have a web server listening on localhost, what can I post there or get endpoints so that I can interact with your computer? And the sort of primitive here would have been, if I send you a link and I reboot your computer, it's funny. But what else is there? But POC or get out. So one of the things I'm going to do here, because I don't really want to use this on Windows, is I can't remember these commands. I'm going to put a port forward on my Windows machine so I can reach that 53,000 from the outside. So it's bound to localhost only, but I want to curl from my Mac. Of course, I need to do that as an admin. Bear with me. But all this means is just I can now access this port on from the outside. I'm going to make a call request here, assuming I copied that. And let's do -v. Of course, 50. What is that port? Yeah. So this is, there's no hack here. This is just to make my life simpler. And because I prefer curl over PowerShell, I can do this. So we now see we get a 404 coming back. Sort of gives us a sense of what that web server might be doing. We know if we go from the reversing's perspective, we have this endpoint called, this is v1 reboot. I hope I copied that now. Yes. So we see another 404, but some more reversing. You'll see is actually a post request that goes there. And so we post to reboot. It's going to take a second. We get this access denied that comes back. Okay, so my theory is if I was to give someone a URL that would post to localhost, obviously with some JavaScript, it would do nothing. There will be this access denied thing. Now, the beauty of access denied is a string. So a hacker's favorite tool is, let's take a string. We already see a reference to access denied in 2 places. So we can look at one of these. We can see, okay, this looks like potentially some origin checking related stuff. That's interesting. Mostly because of this is origin allowed thing. That's sort of the oracle here. Not because I know what any of these functions do. I'm sort of making a very quick assumption that maybe this is origin checking related. And the second reference here is similar. So, okay, this clearly has some relation to origin checking. So that's the first way you could have learned that. The other way you could have learned that, if we go back to the VM, is a lot of these tools are amazing in their logging. They will tell you a lot of things about what they're doing. So if we take, for example, if you were to use Process Explorer, you can open the lower pane here with this option, which pops open this process-specific pane, which gives you this handles view. So you can sort of get a sense of which files, potentially name pipes, ALPC ports, etc. it has. And one of those file sections, usually, if I'm not going to be lying to you, is a log file. So we can see this adu.exe has a handle on this log file in program data, ASYS, whatever. So let's go there. I'm going to manually just browse there with my file explorer. We see there's quite a few log files here. So the assumption here is obviously there's some rotation occurring or whatever. And the one that's clearly being used here is this ADO3. One other thing we might want to do, sort by date modified, just make sure we have the right one. So what I'm going to do is open a terminal here and then just use some PowerShell, get content on that ADU03, show me the last 4 entries, and then wait for new lines to come in. So we can already see here is like an entry that relates to is origin allowed. It's denied. But let's just check that we're actually reaching that web server. So I'm going to run it once more. Let's observe what this log file entry shows. So there's a new written run here. So clearly there's an origin related problem here. Is origin allowed? No. Now, I'm making a bit of a meal out of it because this origin thing is really important. If you don't know, an origin header is a header like this that the browser automatically adds when making an HTTP call from a browser. So we'll see the real one is here. This is not something a developer can control. You can't change this. There are more modern headers like these ones, these segfetch related ones that modern browsers support. More interesting things here about where did the request originate from. But what you should learn from the origin header is just this is telling the web server that this is where the request came from when the same origin policy applies. So driver help.asus.com is obviously where this request came from. So let me add that. So we'll do the post again with an origin header now. And we're making an assumption here based on strings that the origin header matters. We get a 500 coming back this time, so it's not a access denied. And if you've ever worked with this stuff, there's a new error is always an excellent error. It means progress. So in this case, it looks like some JSON-related actual body content that we get, which is interesting. Sorry, not a body. This is a response header telling you what the exception is. The body is empty, but there is some JSON issue here. So that's one hint you can have that you need to pass a JSON body. The other hint here is if we go back to our log files, this is sort of where we stopped last time. We can now see that our header is okay, but the request body is empty. So clearly the post request requires some content. And what that is, at this point, I don't know. I'm sort of passing an empty JSON that says the reboot fails. So the response is much faster, as you can see, but obviously an empty body is not enough to reboot someone's computer. So one way to figure out what that is you can reverse this more. I wouldn't recommend it, but you can for the intellectual exercise. Go to this function and try and understand what exactly, my hint to you, oh, sorry, that's the options request, sorry, this part. There is a very clear section here that's looking for the JSON structure. These case statements, actually quite a popular JSON C++ library they use. Or plan B, which is what I actually did, is if you look in the browser dev console, you can view the sources for this application. So a little bit of JavaScript hacking, very basic web hacking. And we go to this chunk section. There's some packed web app. Webpack is probably the hint here. And what you can do is you can search in here. We might go reboot. Now, search for references in reboot. We see there's 0 references. So I'm sort of going to click through them. Still no references. I'm just hitting Control F and searching until we hit a match. What did we hit here? No, we didn't hit something. I'm hoping this hasn't changed since, by the way. That would make it weird. but this is the live site. Okay, there we go. Here's the reboot endpoint. So just based on these, I mean, I don't know what any of this JavaScript does yet, but I sort of get a good sense that like this function, it's minified and obfuscated, it's a mess, but at least some HTTP requests potentially exist here. Now, this took a little longer to get to where I wanted to, but eventually at some stage I was looking for, are there any post definitions? Because I kind of knew this JS file was now referring to HTTP requests to that local web server. What post request can we see here? So here is potentially a post request that's interesting. Sort of click through them. I see here is a body, which takes a list and a URL. That's a really important one. We'll get to that later. And here's one that has reboot. I'm like, okay, cool. I can sort of make out of this that the body needs to have a JSON object with the word event and a list of objects with command and reboot. So let's give that a whirl. So we have an object. Let me just double check. We need event that we need to get, and it wants a list of objects, which wants CMD, and it wants reboot as the command. So I'm going to send that along. It says the reboot's okay. And if we look at our VM, it reboots. Okay, now I've done no hacking actually here. I've just sort of re-implemented what the web browser is doing, which is an important precursor. Sort of looking at these vulnerabilities, I'm now able to replicate how Driver Hub interacts with it. And truthfully, I almost left it here, realizing that if I can't interact with this web server from anywhere other than driverhub.asus.com, well, it's a weird architecture. It's not, it's not something that's obviously vulnerable to something that I could find initially. However, I did decide, talking and typing a password is impossible, it seems. Hold on. Someone sniffed my keyboard. Going back to this, realizing the origin check might really be a tricky one to bypass. That was really the hurdle that I had. Oh my goodness. So I decided to go a little bit deeper. What can we find for this origin checker? Go a little bit through this reboot function, get to the part where is origin allowed. We sort of zoom in a little bit over here. So we see a check here for if this RAX is 1. So if some variable is true, and it's based on the return of this function. So this is probably where I need to go. And it's also a little bit above what looks like a logging entry, a log line. If I go in there, this format string looks like it could be some logging thing. We could probably rename this function go and say logger, just because we sort of think that's what it is. So if we see this again, these are all logging related things. But this RAX2 is quite important. So we go into that function, takes 2 arguments, can immediately see a reference to the origin string. And then I need to now also find this function. Sort of have a quick scroll through what is happening here. Oh, this is actually quite big. They have lots of checks for like, is it localhost? Is it a dev environment? Sort of like, I think quick exits out of this function to allow. It has this block for access denied, which we can see as if these two are the same. That's interesting. Where's RDI1 set? So let's set to this value and comes from here. So I'm sort of like following the stack back to find where this happens. Okay, and that's typically how I would look at this. Like which variables define which paths we're taking. This looks like an access denied path. But let's continue reading. Here's obviously if it's on localhost, some matching. That's weird, but okay. Anyways, eventually I got to this line, this specific line, an assignment to RAX that clearly has a code path to go somewhere else. But the string .asus.com in my mind went, okay, this is probably where the check for is this an asus.com origin. And you can imagine they did this in case driver hub changes. Maybe it's new driver hub or driver hub 5. I don't know, making names up here. So we go into this function. We see it's like actually quite short, but there's a very critical part here where there's a mem compare happening over an iterator, which made me realize that actually this might be a substring search. You see, if we click on this function and see where else it's being used, you start getting a sense of the arguments that gets passed. There's a boundary check. Not sure, this might be some HTTP protocol check related ones, some headers, disabled country. I guess if you're in China, there's some condition there. yeah, there's a lot of like interesting inferences you can make over here. But more importantly, if we follow along what these arguments are doing, we'll see there's an iterator comes off whatever that response is. If I'm guessing this might be some size check or something, I don't know. But then we get the arguments that come in from the originally caller function, arg4 and arg5. If we go one back, we'll see arg4 and 5 is aces.com, which is also nine characters long, conveniently. And so we can check in this function that loops for 9 characters. And if it matches the length, if the memcompare actually comes true for those 9 characters, the function returns. And therein lies the bug. If we think about this, what that function is really doing, if we wanted to watch driver hub.aces.com, does this match .aces.com? The function will go through these steps, keeping 9 characters in the buffer, and continue until the .aces.com matches aces.com, in which case it goes great. This is clearly where the origin is. But the challenge is because they bail early, you can go aces.com.local, and that function will return true because .aces.com is in the string. It's a string contains. And that's what this function actually does. This string contains. Okay, so if the string contains aces.com, and we already know we can append anything else, it means our curl request can have an origin to reboot someone else's computer. I've lost my cursor, it seems. Aces.com.local. So this is not the real, let me maybe make that a bit bigger so the whole string shows. But this is not driver help.aces.com, the real web server. .local, now I use .local here. This can be, I don't know, google.com if they are so inclined. I'm not saying they do this, but that's possible. So if you browse to a website that hosts driver help.aces.com's content on a different domain, you could potentially interact with this. So let me look at my VM. That's unrelated to this. I'm going to send that payload. We get the reboot okay. And therein, we're able to learn the origin check is not being done properly. And so where I would have initially just bailed and said, no, there's nothing to see here. Actually, because the origin can be arbitrary, this is actually a problem. Anyone can send you a link. You can click on it. I can interact with the local web server. And up until this point, I can reboot your computer, of course, but which is not exciting. But of course, we want to elevate that later. But the critical part here is the fact that any origin is allowed in this case. And that's because a string contains is being used. It's not an absolute check that it ends with .aces.com. If this check was ends with, not strings contains, there would have been no vulnerability here. Okay.
That's a neat one. That's a neat one. I can see you reliving part of your you kind of curiosity thing too, where you're like, wait, I gotta keep digging and digging and digging.
Exactly. And it's sort of like I isolate, like I realize this is the key security feature that's sort of making this exploit impossible. Let's just double check that they're doing it right. And it's something that has paid off through this entire research. And we're going to see another version of that happening shortly. So
And someone asked real quickly, just because it's relevant, does the token privileges modification of setting reboot priv, does it limit this to only being able to reboot, or can you edit the token privileges that are being set?
So the token privileges are really just to adjust them so that you can reboot. That's it.
Yep.
You don't have control over the Win32 API that's being called. Sorry, this is still in the origin check.
That'd be a sick bug.
Yeah. If I could make any arbitrary API call, would have been amazing. But no, it's really exit Windows is the path that goes finally. It's the final check here. That's it. Then it checks out. It's also, I later learned these 2 flags mean like reboot, like right now, immediately. Don't pass go, don't collect $100, just reboot, which is a little frightening from a web server, when a web browser. Okay, let me check the VMs back. Okay, so reboots are funny, but really that's not where the magic is. We want our code exec. Code exec is really where we want, and spoiler alert, we'll find that. One out of all these endpoints, one of these endpoints is the update app endpoint. It's this one. Again, it has an options and a post request handler. I'm going to go straight into the post request handler, which is here. And you can sort of read this function again, which is quite big, as you can imagine. One part that eventually, I'm going to go a little bit faster over here. You'll see in the JSON parsing, once it's passed the origin check, which happens here as well. So again, if the origin header check was correct, this probably would have been less of a problem than what it is today. So what I'll do here is a, I'll say some of the reversing, but this sort of extracts the name key. And then there's another one here that Binary Ninja struggled. Status name, let me just double check. That's not it.
And users of security, thanks so much for gifting us subs. Really appreciate it. Helps us give back to the community. Thanks.
Sorry, this is not very exciting reading JSON parsing. Okay, somewhere over here, there's some, like it took very long for me to figure out what's happening in this function because you can see there was a list variable that was being referenced. Sorry, I'm lying to you. I haven't seen list yet. Okay, regardless. The point is, you'll get to, we were looking at the browser's sources. I actually need that, so bear with me. We need to redo some of this dance. You know what I didn't do? I didn't update. I didn't save my rules. Let me just go to the real driver hub. It'll still have the JavaScript there. Open DevTools. Where's the sources tab in Edge? Okay, I will need Burp for this. I only use Edge to download another browser, unfortunately. Elements? No. Console? No. Oh, sources is literally there. I'm blind. That gets much worse after 7 days, I can tell you. I think this one had the post. That wasn't this one. Maybe one prior. That's add. They've also added, like, they've added some new endpoints, which I wasn't sure of what that's all about. Oh, I might know a faster way to get here. This one. Okay, so I'm short-circuiting a little bit of this, but you'll sort of have the same dance here on how do I interact with this update app endpoint. And what I mean by update app endpoint, we're going to curl. We'll have a new payload, and we're going to have a new endpoint, which is going to be update app, if I have that right. Let's just double check. Update app, this one. You know, because people are looking at my screen, I'm going to copy this, just make sure I have that correct. You know what it's like. You can type fine until someone watches you use a computer. Okay, we'll still use the poisoned origin header just to check a new endpoint. And now we need to figure out what the payload needs to be. Like, how are we going to send something here? I don't need burp anymore. What would be nice is to know what the log file for adu.exe is now. Let me get there. Which is this one. No, I just need to know the log file. So I click it. That's the web UI log. As you can see, lots of interesting things. It's rotated to 1 now. I sort of know this because I stared at this for a long time. So I'm aware of the dance it does to confuse you. Okay, this one. This log file is exceptionally helpful. Like, I could almost close Binary Ninja at this point. Get content, ADU01. Let's just see 5 lines, and then we wait for new ones. Okay. That's WebSocket related. Not interesting now. So we send an empty one. You'll see another, we expect some JSON. In this case, post update app is the actual code path we've hit in adu.exe, but we need to figure out what we need to send it. So we're going to do that by reading the JavaScript code again. We can see we need a list, which probably needs a list. A list of objects that contains a URL and a name. Spoiler alert, you don't need name. So if we set the URL, when I was looking at this the first time, is like, oh, cool. What happens if I ask it to download google.com? It fails. It's not unsurprising. But we can see the first hint here that we have that agent URL cannot find .aces.com in google.com. And because we already know that, sort of the assumption they made is, okay, I've seen this before. I don't know where, but I've seen this somewhere.
Yeah.
So what if it was from, no, that's not there. aces.com, sorry, it needs to be dot. So let's go test.aces.com, not google.com. Google's getting a strange request now. We can see, okay, we've got some new lines. The error is now different, that it can't download anything there. That's probably not a real domain. But the check that the thing that you can download in the update app endpoint comes from aces.com doesn't work, because they're obviously also doing the string contains here, which is nice. So what that means is, if we have an arbitrary web page on a domain I own and an arbitrary URL to download on a domain I own, as long as both of them have .aces.com in it, we can get to this part of the code part. So we're going to imagine a little bit of that. I'm going to run Notepad and edit my hosts file, because I don't want to actually spin up a web server for this, but you're going to have to play along with me here. Those were, oh, of course, that's going to happen. Oh, my word. Run as admin. Yeah, and what I want to edit here is the hosts file. So that'll be in C, Windows, System 32, driver. We'll go to Etsy, and we want the hosts file. I'm actually just going to check what I actually called it. So here we can see exploit.aces.com.totallylegit.local. And that'll resolve to my host OS. This is really just a, it could be a real domain that hosts to some that resolves to something on the internet, but I don't feel like any of that effort. So let's take this URL and we give it a handler, and now we sort of satisfy the .aces.com requirement, and the VM of course knows how to get there. The next thing I want to do is quickly get to another folder, so we can, I want to host a little web server here so we can see what's happening. So we go Python, I think it's http.server. And it's really to mimic as if you have a server on the internet. Sorry, server. It listens on port 8000, so we need to update that. Port 8000. And what we're going to now do is we run the update app endpoint with our poisoned header and a poisoned URL path, which the app obviously shows that it's accepting. And we see a response coming back here for the roots of the page. So clearly we can invoke the driver hub app to interface with some arbitrary endpoint if it needs to. So in the logs, just briefly, you can see what this looks like. Our first hint here is already it's managed to download that root page, but it also helpfully tells me the that root.html is not ACE's signature, so it'll quit. It wasn't a binary to start with, but here we are. Okay, so with the primitive we have here is we can actually download something to run. So we can use something like Metasploit. Very, very, very simple. There's no magic here. Just running it in a Docker container, but I'm using MSF Venom to generate me a Windows exe that will just run Notepad. That's it. And that'll be written to pwn.exe. So let me just check that I have pwn.exe. So now if we do our curl request again and we go /pwn.exe, we should get the same result, except this time it's actually an exe, but we can see driver hub downloaded it. And we're going to get this ACES signatured false error. Now, quite a lot of products actually do this right. The ACES signature checking is pretty okay. And if you were to do signature validation on a PE, you'd use a Win32 API called Win Verify Trust. But notice that it's not imported yet. And when I saw this, I realized, hold on, how are they doing this signature validation? So using hacker's favorite tool, we'll search for a string called ACES signature. We look at the references for that. So there's a logger. We've already renamed that earlier. And we're going to have a look at what the code path is here. It's in an else block. So of course, the true condition's at the top, the false is at the bottom here. And we continue checking a little of this file. You'll go into some of these functions and get a sense of, that's actually too far already. I think it's this one. Let's just check one of these calls. RAX. This is not the part I want to get to. Dun, 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 dun. Oh, sorry. This is the actual value. So here we'll see these. This is the function that does the signature validation. And if you go into this thing, you'll see it actually uses a Win32 APIs to extract attributes from the PE that it's reading, but it never runs Win verified trust. Like it never checks that even though attributes exist, is this thing signed by a trusted CA? It just checks that this word Asus Tech Computer Inc. exists in one of those attributes with the string compare, which is not signature validation, which implies if we just copy these attributes to any exe, the theory is it'll work. Now, thankfully, that work has been done for us already. So we can run a tool called SigThief. SigThief, I think that's what it's called. I always need to look up these arguments. The in file. Oh, and we can steal it from a legitimate binary. So we know like adu.exe is legitimately signed. So let's take adu.exe's signature and we apply that to the target, which is going to be pwn.exe. I think that's all I need. Yeah, and we now have a new pwn.exe signed. And the interesting thing about this, it's not validly signed. It just has the same attributes, certificate attributes as adu.exe, which is handy, which means, sorry, let me do this. And this curl, big fonts are hard to work with. Pwn.exe, I just need to get that name that's signed. Oh, I might need to rename that, sorry. Let's move pwn.exe signed to pwn.exe. I don't worry about the original one. And we run the curl. Okay, so that should match. Let's just go back to our screen. I'm just going to close this for dramatic effect. Go away, go away. Gee, how many pop-ups are there? And enter. It fetches the exe, and we go back to our VM. Notepad opens, which is amazing. Notepad is not signed by Asus.exe. I can tell by Asus. I can tell you that. So that's the vulnerability. Now I realize at this point this might be confusing. You're gonna go, hey, you've opened this web server to the network. You did a whole bunch of things to be able to get here, which is fair. This is why we need to look at a demo of how this would really look. So bear with me for 1 second. I'm going to show you a small video here of what this would look like from an attacker's perspective. I don't have the web server prepped for this already. So what I did was, let me make that bigger. As big as, I see, okay. Actually, I don't have the URL bar here. So what happens here is, imagine now that pwn.html has some JavaScript in it. Maybe I do have a copy of that file. Hold 1 second. Maybe a chance for me to, we're going to see where my research is now. This is the ACES one. I think POC, HTML. No, I don't need to copy that. I'll just open this. So one of the really, really simple POCs that you can do here is I have a very basic HTML page that has a self-calling JavaScript function, just what you're looking at here. And then it makes a HTTP request down to the update app endpoint, which then passes in that URL that we just saw with our POC that we were building with the kill command. What this means is get someone to browse to this web page and have a vulnerable version of adu.exe or Asus Driver Hub. You will be able to have this arbitrary executable run on their host, making it a one-click RCE.
Wow.
Obviously, at the end of all of this, I was exceptionally excited because now, now I have a cool bug, and that sort of was the high that I used to find all of the other ones. There's an interesting bit that happened here with Asus. So I obviously report this to them. As disclosures go, it's a bit of a hit and miss sometimes. They have on their website, they have a WAF, so you can't submit POCs. The WAF blocks you. So I needed to make secret gists so I can send the POCs to them so they can actually debug this. But anyways, and then when the CVE assignment came out, about two days later, I noticed a blog post by I think it's a researcher from Australia or New Zealand somewhere, Mr. Bra. and they have exactly the same thing. And of course, I don't know if they didn't think we weren't going to talk to each other, but sort of asked them like, oh, it looks like we had a duplicate finding here. What did you find? And it turns out, long story short, I found it 2 months prior to them, but ASUS never let them know when Mr. Brower reported this that they're already aware of it. It's a duplicate or whatever. So they sent us the exact same CVE email saying congrats, it's been assigned, whatever, which is not great. But to Mr. Brower's credit, he went along and hacked a whole bunch of other things of theirs. So I recommend you have a look at that work as well. But anyways, so that's the ASUS Driver Hub stuff. This got fixed. If you install the latest version, this vulnerability does not exist. But there are arguments to be made about other attack surface that might be interesting to look at. Okay, so that's what. Sorry, I don't know if there's maybe some questions. So the next part I was going to go to is to very quickly go through the Razor LPE. Yeah.
Yeah,
I need to reset a view.
Maze was asking, do you use program analysis techniques to find vulnerabilities, like using taint analysis, sync, sources, and sanitizers?
Very rarely. The interesting thing about this is like, if a target was boring, I moved on very quickly. Legitimately, like, it was not an interesting. If it didn't have an elevated service that I could interact with from a low privilege space, then I thought, nah, I'm going to move on. Maybe something else is more vulnerable. So a lot of these vulnerabilities can have significantly more depth, as evidenced by the Lenovo Vantage example. The bug is really cool.
Yeah, if you do have questions for Leon, be sure to post them up here. So we're probably looking at the last piece here, which is awesome.
Cool. Okay, so the next, this VM is going to take a second. Is the next, I can close this one. No, frankly, I can't close it. That doesn't matter. We're not going to do these two anymore. Just like to make these full screen so my context remains sane. Okay, the next part is Razor Synapse. The reason I chose these targets, after ASUS Driver Hub, everything from here was random. The concept of what exists out there, I would furiously Google what products exist. And Razor really just came on my radar because they're the ones that I saw next. Now, I don't have internet enabled here. This is for a reason. Their updater is very good. So I'll show you a little bit. We're going to revert this VM twice. It has no internet connection on purpose. So when I triage these kinds of apps, I always go to SysInternal's Process Explorer, run as admin so I can see all the things, usually sort by company name. Sorry, that's a little frustrating to watch, I'm sure. Company name, and I know I'm looking for Razor. And like, special shout out to them for the number of processes that's running here for me to tweak my RGB. It's just honestly incredible. But okay. The first process that would pop out at you is this thing, very aptly named Razor Elevation Service, which I figured I was told is a magnifier. This is a little more interesting. The Razor Elevation Service, like, it's a little bit in the name. So the spoiler alert here is this is where the Provesk existed. But it's a 64-bit executable. You can see, I'm going to try and drive this. The Razor Elevation Service runs as system, which is fantastic. I really like that. But the challenge for this one, some apps have TCP ports. You'll look at this and go, are there any listening TCP ports, like adu.exe for Driver Hub? Was this listening on 53,000? Are there ones, yes or no? You can check these out. That might be one indicator, but there's none here. The other thing I usually look at is, this is harder to drive with a magnifier than I thought. The other thing to look at is in the handles view at the bottom. Sometimes there might be some named pipes, which could be another way in how someone interfaces with, oh, I need to stop this magnifier so I can actually use this. I'll zoom in again in a sec. Those are keys. Okay, actually the file, there's no name pipe here. It's usually shown in the name, like /device/name pipe or something like that. And so, like, the way the RPC works here wasn't clear to me initially. There are many other options, But just a cursory look like this wasn't interesting. One of the other things you can obviously do, just going to minimize these to make the screen real estate a little smaller. That's the wrong app. Is use a process monitor. Process Procmon, more aptly known, is a way to quickly see some Win32 API calls that are being made.
It's best when you don't use any
there's-
filters, of course, right?
Yeah, it is. But in this case, I'm really just interested in the elevation service. Otherwise, the stuff that comes out here is unreadable. It's just way too much. Way
exactly.
too much. And so what happens here, I'm going to enable internet now. This is probably going to, you can already see a new thread created over here. The GUI app here this is an Electron app, which is why it has 1,000 things. And so what I wanted to sort of initialize or get a sense of is what interacts with this elevation service. Like, what must I do in the app in some way to have the elevation service do a thing? Why would that be? Now, I imagine here, this is hardware management things, RGB, etc. I don't know a lot about the underlying implementations, but I imagine something obviously needed the elevation service. One thing, I finally clicked the Chroma app installer. Nothing. Yeah, I clicked 1,000 things. Nothing triggered it until I clicked the installer for the Chroma app, which may or may not do anything now based on it's still figuring out that it has internet. Of course, that'll happen because I moved the window. But eventually you'll see over here, oh, there we go, some activity. I'm going to pause that. We'll see that an installer got written to a path over here. Actually, that's a close file. And at some stage, I may have stopped it too soon here, but at some stage, this actually gets run, which is how I got the elevation service to trigger, which is interesting. We'll now start seeing the Chroma installer doing its thing. I'm not going to revert this. Oh, sorry. So the last thing to say here, Procmon is really useful to sort of get a sense of what activity a process is doing, filter by that target, and see what the interactions were. The thing I learned here is if I install something by Razor Chroma, the UI, that somehow interfaces with the elevated service. So there must be some sort of RPC mechanism between the two here. At that point, I wasn't really sure how this stuff worked and what that mechanism was. For the keynight, I'll scroll up very quickly. The hint is already here. I'll spoil it a little bit later, but if you've done this before, you would see exactly what the RPC looks like over here. And that's maybe something you'll learn in a sec, is what do these things mean? That's sort of what tells you what this current RPC mechanism is. So I missed that initially. Okay, so because I don't know how that works, my target sort of turned to, I need to reverse this UI, this Electron app. If you've ever reversed Electron apps in your life, you'll know that can be a big hit and miss. So what I needed to do was find the path of where this is installed. And if it's an Electron app, there is this archive of the entire app, all the JS, all the HTML, blah, 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 usually in a thing called app.sr. So, it's in a resource directory. The version that I was looking at here was there, but I'm going to copy that out. I'm going to move that to my oh, that's not the share I need to share. One sec. I reverted a snapshot. One moment. Take this back. I'm going to move it here. Okay. Back to this. No, that's not. Did that not?
I think Electron came from Chrome and Node.js. That's to thank for.
Yeah, exactly. That's why there are so many processes there, right? Okay, here we go. App.sr. What's really handy about it is like the Node.js folks have a really nice tool that lets you extract this archive. Let me see, SAR, this. So I'm using npx, which is just run an Electron based, a node dependency. And this SAR has a CLI entry point, passing the extract argument, giving it the SAR I want to extract, and then a folder where it needs to extract to. So if I now go to client, I can now start seeing things related to this app. Obviously a reference to the GUI client. So now what I typically do is I sort of add that into some sort of tool that I can read the source from. I'm going to add this folder to the workspace. I'm going to add the client. Of course, I trust this. And now I can sort of read a little bit, get a sense of what dependencies are there, blah, blah, blah. Okay, so we're not going to take another hour and reverse all of this, but this is where the pain comes. Like there could be nothing here. I might be looking at all of this and there's no real win for me to have. Until you get to this modules, I need to remember now, FFI, no, not FFI, simple service, win. So it turns out, one of the things I usually do is, you can view, there's probably a VS Code extension from this, JS beautifier. This, I sort of paste that minified JavaScript, copy it back out, and now I can also read it. What you'll see is actually a reference to a thing called FFI nappy RZ, which is it looks like a Razor private fork of a public foreign function interface library. And it's sort of the mechanism they're using to make calls out to native code from Electron World. So there is actually a DLL on disk in one of these directories of the Razor app, wherever that might be. One of them, actually my common DLL, oh, here we go. There's the simple service DLL. So that DLL actually gets loaded in the client, and they use this FFI to be able to make calls into that DLL. What's really interesting here, if you've ever used Frida before, when I looked at this the first time, I'm like, wait, are they using Frida? Because this is how you would typically define function pointers and things to make calls. But no, it just happens to be the same looking interface. But you can see these references to a whole bunch of functions with obviously native code related arguments, pointers and strings and null arguments. But what you'd learn here is, okay, so that's how the Electron world gets to the native world. I lost track of what I was trying to do initially over here because this was too interesting for me to let go. And so one of the things you'll learn here is when you start interacting with these services. Sorry, I of course have that simple service DLL here as well. Do I have it? Just double check. No, I'm going to copy that out because I have it handy. That's so annoying. Why? Taskbar, go away. Windows, paste this, simple servers. I'm just going to open that in my Ninja. This is obviously native code again, which is handy. And here we're just going to look at the triage summary because it'll show us the exports that this has. And looking at the export list, it's very easy to see that these things map to the JS that we're looking at over here. So we have a reasonable confidence that these these function calls map to the functions that are exported by this DLL. And that's sort of how the Electron world speaks to this. At that point, I yeeted that Electron app. There was nothing for me to do there anymore. And I can now interface with that simple service DLL myself. The source code here is still interesting for some references. You'll see, I'm going to take a chance and maybe see this one. Sometimes these functions, okay, initialize actually doesn't have any arguments. Let's register an event. Some of these function calls actually has an idea of what the logic needs to be. So this gets a little convoluted. You sort of really have to keep your wits about you. But you sort of get a sense of like, okay, what is the function call doing? How is it being handled in the JS size? And you can sort of make inferences on what's happening in the actual DLL. In this case, there's some callback mechanism that it gets quite complex eventually. But okay, so the strategy I had is I started realizing I think this DLL, this simple service DLL, based on all the references I've seen so far, is clearly what's interacting with the Razor elevation service. This is sort of the connection I started making over here. And so the way I eventually started implementing that was I would load this DLL myself. There should be this Razor main. I would load that DLL myself. Whoops, ignore that. Let me just see. At some stage, there'll be a load library here. Let me just go to the main function. You sort of get a sense of what's happening. The size makes it hard to see. I'll zoom in again in a sec. Okay, here we go. So we have a load library for that simple service DLL, which exists here. And then we start getting handles on the actual functions that I've started being interested in. And the only reason for this is I want to make those calls myself so I can start learning on how this interface actually works. Like, how do we get to talk to the elevation service. So this is a very, in summary, a small C++ wrapper around that DLL so that I can talk to it and start learning things. In the interest of time, there's really just one function that's really important. There's a lot of pre-setup and initialization that's important, but there's a function called simple launch user app process, which is exported in that DLL that you can call. It took 3 parameters and a callback. This code is public, so if you look at my GitHub, on our organization GitHub, on SensePost GitHub, you'll find a bloatware pwn repository for the source of all of these exploits. But it needed some wrangling, or what do these parameters mean? Where do they resolve to, etc. Anyways, what it really boils down to is they try to isolate where binaries can run from in this common folder, which is actually relative to like an app data folder that we have over here. We can check that out in Windows in a second. You'll see the common that exists over here. Relative to common, so this is not something you control. You can't change this. But in the case of an LPE, you already have access to the box. So you can copy a file here as an example. So relative to common, which is what the first parameter must be, you then say which exe you want to run, which is the parameter 2. I don't know what parameter 3 does, so you can just leave it empty. And the callback is actually empty as well. So by loading the DLL, we invoke this function. We'll be able to get some code execution, which I think I can show. I think this one will have a better. Oh, that's the actual LPE first. Sorry. Let me just think about this for a second. That POC is something I need to run for you. Oh. See where I am. Razor. Simple service patched. Okay. Let me get to the juicy part here. Bear with me. Okay, so we had I viewed this Razor main CPP. Oh, that's going to be annoying. We had this function we needed to call, and you can get some code execution, but it wasn't elevated code execution. It was just as a normal user, which is a very confusing thing. Until I realized if you go to this folder where this is written, it's app data local. Let's go app data, or it's local app data. I always get it wrong. Local app data. Then, so this is app data local. Go to Razor app engine, user data, and I think it's apps after that. Comment, yeah. So this is the initial, you sort of can specify where you want to run this, is the one argument, and then the actual path to something that you want to run. What's really interesting, if the Chroma installer is still here, it's not here anymore. Maybe it's in the web app. Yeah, here we go. I'll use the magnifier. The initial, was there elevated code execution? It did nothing unless you, I don't know if you can spot that little shield, right, with the blue and the yellow color, which if you double click that, it's going to give you a prompt for UAC, right? It'll look something like this. You double click it, do you want to run this app? And so the Razor elevation service honors this exact thing in a way that when you double click that and it expects UAC, then it'll run in the elevated context. And so my initial test, like this test.exe, runs as a normal user, and it's like a wildly confusing experience, actually. Yeah, I'm like, why is an elevated service not running in an elevated context? Turns out supporting this. There's a thing called, I'm gonna skip it for now, but it's called a side-by-side assembly manifest that you can check out. You can manually add one of these to a executable, and it'll force elevation. Windows has some heuristics where if it looks like an installer, it'll ask for elevation, but this is sort of the more predictable way. Okay, anyways, all of that is to say, like, I did a whole bunch of POCing the simple service DLL, checking how can I interact with it, etc., only to have a colleague tell me that my exploit is too complex. Now, I want to show you very quickly what the exploit looks like, just so you can get some of that. I'm going to close this. Oh, I need to check if I still have the vulnerable version of this running, please. One sec. It may have updated already. Let me check. Just going to check the version number on the Razor elevation service. I still have 105 running. That's fantastic. I don't know why it didn't update, but I'm not complaining. Then let's go to the share. Let's copy this out. Just as an example of what's happening here. Now, we don't really have a lot of time to cover this one, but one really interesting thing that I realized, it also had the same side effect like I had with ACEs, where at some stage during the reversing, I get this PE signature related error, where it's, this is not signed by Razor in this case. And it turns out that logic existed in this simple service DLL, which is something that a user controls. As a normal user, I can change this DLL. And notice how it's next to my POC, right? So what you're looking at here is a patch DLL that has PE validation. They do it correctly, but I patched it out using Binary Ninja. The exe that loads that DLL to start invoking those functions that I learned about in the Razor world, that will ultimately run this add user command. Let me do one more magnifier so you can sort of see. It also has that shield. So I have this like side-by-side manifest added to it. Okay, where's magnifier? So quickly, how that looks is I'll do, let me just do net user. So what I'm doing over here is adding a new user. So if I do net user add Razor with a password, I can't do that. But if I do Razor pwn, it's going to load that DLL, which also has an insane amount of verbose logging. This is the DLL's logging. The little window that just popped up was the add user sub process that ran. So if we go net user, we have a new add user added. I was very pleased with this. It was a lot of work, but I finally got a user added. But the reality was I didn't really understand yet how it was possible for this to speak to that elevated process. And that's until a colleague told me, have I looked at COM objects yet? Which is those class IDs that you saw in Procmon earlier. And it turns out I did not. In fact, COM objects are not really an area that I focused on much. But it turns out that entire process could have been a one-liner. You see, if you open OLE view and we browse class IDs by server, I know this is very small, but if I change this font, it will, I might be able to magnify this a bit. The app doesn't do too well. And if I go down to Razor, that's parallels VM. If I go to this Razor elevation service, we'll see, first of all, it has a COM object. It has a class ID that you can see when you hover on the class. Oh, that's bouncing around a lot. Give me one sec. I'll magnify in a second. It has a class ID, which if we just right-click this and go properties, the most important thing that you really want to know is this prog ID, this rzutility.elevator. Because with that prog ID, we can interact with the COM object from PowerShell. So I'm going to show you how that looks quickly. We'll assign a new variable. Let's just call it T. We'll say, let's instantiate a new object. This is a COM object. And we use that prog ID. You can do this in OLE view directly as well, but I think showing it as PowerShell makes it quite simple. So let's imagine you have an object T in PowerShell now. We can just see T as a COM object. We can also do get member on this, or GM. It's the same as get member. And that tells us what kind of functions are here that we can run, right? Which is interesting. You can really see where this is going. So all I really needed to do was launch process. I use the no wait one as an example. I'm gonna just say C Windows System 32 Notepad.exe. The second argument is a string. I don't know what it does, so we keep it empty. And I also don't know what this unsigned integer does. So I'll make it 0. Yeah. And we launch it. And at the back here, we see that that notepad came up.
Nice.
But this is not an elevated notepad. The way to make this an interesting POC is, again, adding that side-by-side manifest so that it does it in an elevated context. And then whatever exe you wanted to run, you'll run as, run a system. So all of that complicated reversing, which intellectually is really interesting. Like I learned a whole bunch of things about the internals, etc. So I wouldn't call it a waste. If my purpose was I just want code exec, I just wanted an LPE, all of that was a waste. This would have been easier. But learning that the PE validation is in that DLL and all of the work to get that going was still an interesting intellectual exercise. But yeah, this is absolutely a much simpler way to get to the same point, and it would have taken you not even a minute to find it. So maybe you have another process that's vulnerable to the same thing. Yeah, and that was sort of how the second bug looked. I think that's what I wanted to show.
Nice. That's awesome, man. Thank you so much. There's definitely lots of positive comments. Not too many questions, but lots of people watching and positive comments. So that's always a good thing.
Nice.
The
That's
do you want to do a quick summary of not showing it or anything, but the other bugs you found? Like what else did you find during those 7 days of
yeah,
no sleeping?
for sure. So like a quick reminder for myself, one of them was in Acer Control Center, I think it was called. Acer Control Center had a Windows named pipe that allowed, well, two things was interesting about it. One, it's the way to get to an elevated server, so that was a part that needed to be true. They implemented a custom binary protocol, which was the elevated side, the process that was running a system was a C binary, like hard to reverse is sort of what you need to hear here. But the client side was written in .NET. And what is really nice about that is you can rip that .NET out of the reflector, put it in your own binary, and now I can speak this. I don't know what the protocol is, but I can speak to it now. And it had these nice wrapper functions. One of those functions was a launch process function that could take a path. So there's your code execution. But then the second argument to that was an integer that in the binary was 113, needed to do some reversing, realize if you made it 114, the elevated service will adjust the token to an elevated context and you would have code exec. What was very special about it is the name pipe allowed remote connections without authentication. So this was remote elevated code exec on their platform. Of course, on their control center. The other one, well, notable one was MSI Center. Similar thing, TCP protocol that took a binary stream in, but responded with JSON, which when you look at this on Wireshark for the first time, you go, what am I looking at? This is confusing. In their scenario, there were two race conditions there was one race condition and one much simpler exploit. They had this idea where you could install software, which is kind of the purpose of a lot of these driver hub related things, install something for your mouse or your whatever. So you would ask it to install something. It would have a code check, a signature check, code validation check, and then it would run a scheduled task that would run that validated binary. But between the asking it to run something and scheduling the task, it would make a copy to C Windows temp, right? Obviously, it's a security mechanism, so you don't fiddle with this thing until it runs. But the problem is there was a disconnect between the scheduled task and what was validated. So if you just spammed this endpoint for run a legitimate program, then your illegitimate program, the scheduled task doesn't know which one was correct. It's always the same binary and C Windows temp that it would run. So it was a race condition there between the time of create, time of use to elevate. Unfortunately, later I found another implementation in the same software that you could just give it a pass and it'll run it as system, no validation. So there's a simpler one. Yeah.
That's great. So I know this question, I saw it in Discord real quickly. I know we're wrapping up here, but if you were to give some advice, like one, do you think there's a lot more bugs like this out there for people to find, and how would you tell them to approach it based aside from what you just showed us? Any kind of high level thoughts?
Yeah, so I had an interesting question with RomHack. It's related. For these vulnerabilities, I sort of consider them fixed because my POCs broke. I didn't feel like spending more effort on it. So, is there do the patches work? Is still an intellectual debate. I know the difference between the Razor Elevation service. The binary was 38 meg. It's 1.7 meg now. So I think most of that thing got yeeted. I also think there are still a lot of these vulnerabilities out there. What I generally sense is enterprise software, less so. Those are always very interesting targets for folks. The HP support exists, the Dell things, the Lenovo. While I thought, okay, actually all's good here, some creative folks already did find an alternative way to get code execution. But their software design is generally, you can see the code quality is significantly better.
Right.
For more consumer grade things, most of the stuff that I looked at, the most of the stuff I had success with, they're sort of in a world where I think not a lot of people look at it, and there's a lot of opportunity there. We had one colleague look at, it's not been disclosed yet, but there's a peripheral, a hardware peripheral that he looked at the software for and thought he found an LPE. And it turns out like it is a feature, like this LPE, there's like part of the software. And you install this is Privesk as a feature. So there's this complicated dance of, are they going to fix it? Probably not. They need it for it to work. But yeah, I think if there's an elevated service, something from a lower privilege context must interact with it. There are vulnerabilities to be found. The teams are large, and they obviously often have to move fast. So they would slip up quite a few times. I think as far as advice goes, one thing I saw in the more mature software, I think RPC is complex. Like Windows is a complex operating system. It's not one way to solve all of these things. But I saw some interesting things. I don't know what the real name for this technique is. So I'm making a name up here. If someone knows what the real name is, tell me. But there's this thing where people are doing what I'm calling caller PID validation, where when you're connecting with a name pipe, for example, Windows can tell you who called by virtue of the PID of who's connected. You need to do some more work to know who called. And then what some products do is, all right, resolve the PID to the backing executable and do a signature validation on that. If that is not the person who is calling or talking to me on the name pipe, then go away. We're not having a conversation. Of course, you get past that by injecting a DLL or getting into the same context as that process, but it comes at the cost, in enterprise environments where now there's probably an endpoint product, EDR or whatever, that's gonna notice something weird is going on here. Many things at play for that statement, but you're sort of you've got more risk in that scenario than you would have if such a thing did not exist. But yeah, it's a really hard question to answer and going, this is the way to do it, because it really, really depends on kind of what your feature set is, what you're trying to achieve. The most secure ones don't have blatant, here is how you run an arbitrary command. The commands that can be run are already defined in the elevated service, for example. So it's really just an invocation that gets done from the caller instead of the telling it what to invoke. Those sort of design principles, I think, go a long way in making it a little harder.
Yeah, no, that's great advice. Yeah, and thankfully, most people don't turn on Windows Defender Exploit Guard with a lot of the mitigations that can stop a bunch of the stuff, even if it were 0 days. But that's good for us, I guess, on the
Yeah, for
offensive
sure.
side. But
Yeah, I
no,
think some of these things could be tricky with sorry, one interesting thing that I did want to mention, sorry for the interruption, is
no worries.
in the Chrome world, and I actually think this has landed. I need to double check where we're at, but they've done like a local host network gating thing, or proposing this, much like if you're, like I joined this call and it asked me, do I want to allow my webcam and
Right.
video camera? A similar consent is coming for services interacting with localhost, which in the case of the ASUS world, it's not, you could say allow, of course, and you probably will when you do it for the real driver hub. But there's an opportunity where you could mitigate the attack surface here just by virtue of the browsers moving in the direction of this is not a free-for-all. Ask the user if they know about this.
Yeah, they never clicked the wrong option, right? No, great. So no, I was gonna say it's getting late here in Bangkok. Well, I have appointments anyway, but this was amazing. I know people loved it, and thank you so much. And definitely love to have you on again if you're interested in showing the other bugs you found. But you've done more than enough, and really appreciate it.
Thank you for having me. Thanks everyone for tuning in.
Yeah, thank you, everyone. I'll announce the next stream. We got a bunch of great upcoming streams. I'll put that schedule together and get it out there soon. I don't think we're going to be able to do one next Friday because I'll be in Tokyo doing some presentations before going back to San Francisco, but we'll do the best I can. Otherwise, thanks again for users of security for the subs, and thanks to, I think it was Sherpa for the donation as well. Again, all that stuff goes back to the community, so appreciate it. But again, special thanks to Leon here. Really appreciate it. It was fantastic. So the demo gods were very nice to you as well, so it's good.
Excellent.
All right, we will see you next time. Thanks.
Bye for now.